Everyone, this will be a relatively short tutorial, and the idea here is to do two things. The first one will be to review everything that we discussed in the course English 601, Research in English Studies, as far as coding goes. So we'll focus on R and some very basic operations and stats overall here in R. And at the same time, it's not only the objective here to kind of review what we talked about, but also to prepare those of you who are planning to take English 686, which is Topics in Linguistics, the topic here being Quantitative Approaches to Linguistic Data. So these two courses, 601 and 686, are connected in a way that makes sense if you think about it, because you start with the basics in 601, the second half of the course, and then you develop more advanced techniques in 686. So this tutorial is really kind of reviewing all the technical stuff from 601 if you haven't taken that course, but you're planning to take 686, but also if you have taken it and you would like to do some quick review. So of course I'll start with the very first step here, which is you have to download R. And you can go to r-project.org to do that. That's where I am right now. So if you go to download R here at the top, you can basically pick whatever mirror you want. You can just choose the first one, and then you download R for whatever operating system you have. Once that's done, shouldn't take too long, you will go to rstudio.com and you will download RStudio. Which you can do simply by going here and then clicking on RStudio. Download RStudio Desktop. It will basically take us down here. Download RStudio Desktop again, so that's it. It's free, right? So there you have it here. So click on Download, and at the bottom again you have multiple operating systems that you can choose from. Just download whichever matches your operating system here. After you have both R and RStudio installed, we can get really started. Just to clarify, just in case you don't remember or you don't know this, if this is the first time you're being introduced to R, R is a computer language and it's meant for statistical analysis. And when you download R, you download everything that the language requires for you to use it. RStudio, on the other hand, is basically a fancier, more powerful, better way to interact with R. So you have to install R before you install RStudio, because RStudio requires or relies on R being already on your computer. Once you install R, there will be a file on your computer called R, and it's really an application, and if you open it, it looks like this, but we will never actually open R. We will just have it over here to really to use RStudio, and that's really where most of what we'll do will take place in 686. It's also what we did for half of 601. So once you've installed both apps here, I'll just minimize my Chrome window here, and I'll open RStudio. RStudio looks like this. Mine is kind of using a dark mode right now. So if you open RStudio for the first time, it will be white, but the distribution will be very similar when you look at the distribution of panes here. So you can see we have 3 panes. We have this big one, which is our console. You can see at the top here. And on the right-hand side, you have the environment with 3 tabs. And at the bottom, we have another pane with the plots tab selected right now. This is where you can see the files in a particular directory and so on. Now, of course, this will be a very brief review. So if you want to get into all the details of each aspect that I'll go over here, you will have to check some references that I have either on my website, which I'll link down here, or just looking at the syllabus and the references in the syllabus for the course. Alright, so there's a list of things that we should do here. The first one is to actually get familiarize ourselves with the interface of RStudio. Now, I want you to go to File and click on New File, R Script. That will bring a 4th pane here, and this is where all the work will take place. Now, of course, we could technically do things from down here in the console. The console works line by line, but we want something more convoluted, so we're just going to work with a script. So I'm going to save this script right now by clicking on the old-fashioned floppy disk icon here. You can also do Command S if you have a Mac, or Control S if you have a Windows PC. And I'll save this on my desktop, which you can see on the background here. I'll save it as tutorial, and it's going to add the file here. You can see it's already there. The extension is .r because that's an R script. Alright, so that's how you open a new script and you save it. So this will be relatively quick, but of course, because it's a video tutorial, you can just pause or slow it down and rewatch it however many times you want before we get started with 686. So that's the whole point here. Alright, so the first thing we can do with R, and this is usually where people start, is really to use R as a fancy calculator. So you can just type random numbers at the top here in our script, and then if you go over here and you click on Run, it's going to run that calculation and tell you the result at the bottom here. So this is the output. If you want to make your font size larger, you can hold out Command on a Mac or Control on a PC and hit plus, so it's going to increase the font size a little, and that's what I'm doing here because this will be better for me and for you to understand what's going on. So at the top of the calculation here, I'm going to add a hashtag for a comment. So this is a random comment, and what happens here is if you run that line with the comment, nothing happens really. It just prints the line, and it doesn't really try to compute anything or interpret the message, right? So every time you want to just type a comment, just use a hashtag at the beginning of the line and then do whatever you want after the hashtag. Now, you can also add a hashtag here, in which case you will be commenting out this particular line. So now if you run this line, it's not going to be computed, right? It's just, it's not a calculation anymore, right? Because it's a comment now. Now, some important shortcuts here. We don't want to have to click on Run every single time, so instead of doing that, we are going to use Control Enter or Command Enter if you're using a Mac. So I can just run this by hitting Command and Enter. This is going to make everything faster, and I highly recommend using shortcuts as much as you can to make your life easier here. So of course you can also have other types of operations like 2 divided by 4, things like 5 times 2, etc., etc. So you can use R as a fancy calculator, very powerful calculator. You can do the typical bracketing. Let's say here 3 plus 4 to the power of 2 divided by 4. This is going to be 2.64 and a bunch of other decimals there. So you can do whatever you want in terms of calculations, as long as you know the operators. So you have the typical plus and minus and slash for division, the star for multiplication, and so on. You also have star star, which is the same as the caret symbol here, the circumflex diacritic for powers. If you want the square root of a number, say the square root of 9, you can also do that. So this is a function that calculates the square root of a number, and you can have a lot of these calculations here. So this is the most basic thing you can do with R, and of course nobody uses R just as a calculator. It's much more than that. And so the next thing we'll do is we're going to discuss variables, right? So variables are incredibly important. Everything done in R is really kind of depends on variables. So I'm just going to type calculator at the top, some examples here, and this is a comment so you can kind of understand what's going on. And now we're moving on to variables, right? Now I highly recommend that you try to reproduce these steps using your own R Studio if this is the first time you're using R, especially if you're planning to take 686. Now we can create a variable by just thinking of a number. Let's just say let's come up with the name of a variable. Now you may remember this from math, right? So normally in math you have the most famous variables are x, y, and z, sometimes w, etc. But you can have whatever name you want as long as it doesn't start with a number or a weird symbol. So we could have something like my numbers, and this will be, let's actually do this in the singular. So my number, and the number will be 5. So if you run this, you can see now that if you look at the right hand side here, we have a new object in our environment, it's called my number, contains the number 5. If you want to have multiple numbers, you have to use a function called C, which stands for concatenation, or concatenate a bunch of numbers. So we can have 1, 3, 4, 5, etc. Now I have 2 objects here. After you have a variable, you can just call the variable by typing the name of the variable. In fact, when you start typing, RStudio is trying to will try to guess what variable you want, and you can just hit enter if that's the one you want, and run that, and it will print the value inside the variable. So if we do that with my numbers, it's going to print 1, 3, 4, and 5. And of course, now you can just run some operations on top of the variable. So if you want to sum all the numbers in my numbers, it's going to be 13. If you want to take, say, my numbers and multiply that by 3, it's going to multiply every item inside my numbers by 3. And if you want to extract a couple of numbers, let's say you want to pick the first element in my numbers, you can use square brackets. This is called slice notation. If you run this, it's going to pick the first element in my numbers, and you can check that that's right, because if you look at the environment pane here, that is the first element in the object, my numbers. Right? So this is a simple example of how you can create variables. Of course, now we're only talking about numbers, but you can also create a variable with words. So let's say I want to create a variable with a bunch of words. Let's say country names, USA, Canada, Russia, Japan. So this is a vector. Don't forget to use the quotes here around the words. So this is a vector with words, and if you run it, now we have a third object called my words. It says CHR here, which stands for character, because as opposed to my numbers, which is a numeric vector, this is a character vector containing words, strings. And just the same as we did before, we can use slice notation to pick a particular country. So if we want to pick the third country here, we just do my words square brackets 3 and we print Russia. We could pick multiple countries, like the first and the fourth country, and we can get USA and Japan here. So again, using slice notation to pick multiple indices inside a vector, right? So this is a very practical way of having access to different items within a particular object, say a vector in this case here. Finally, we have, so let me actually add variables here and vectors as well. So variables and vectors. Another object that we'll need and use a lot is a data frame. Now, there are many other objects, but I'll just talk about vectors and data frames because this is, of course, a very brief summary. Now, data frames are equivalent to your Excel spreadsheet. Right? Of course, they look similar. They work a little differently, but it's pretty much a table, which is most of the time what you will have to analyze in your own research. Right? So it's basically a table with multiple columns. Now, you can think of each column in a data frame is really a vector. And in that way, a data frame is just a combination of one or more vectors in a table format. So that's one easy and simplistic way to define what a data frame is. And we can create one by just using the function Dataframe like this, and we can have something like, let's have 2 columns. The first column will be called country, and it will contain again, the same countries as before. Let's do USA, Canada, and Russia, only 3 countries. The second column will be capital, and this is where we will write the capital cities for these countries. So Ottawa here, Moscow here. So if you run this, now we have one more object, but you can see it's classified as data as opposed to values, because now it gathers 3 observations from 2 variables. So one variable is a country, another is a capital, and we have 3 observations because we only have 3 countries, right? So if we call this variable, you can see that it's printed down here by just running this line, line 30, and we have country and capital, 2 columns, 3 countries, 3 capitals. You can also go over here in your environment and click on this tiny little icon that resembles a spreadsheet. And this will give you a more user-friendly or familiar view of the data frame if you come from SPSS or Excel. I don't actually recommend doing this because most of the time you have a huge data frame, and visualizing huge data sets like this is not very practical. It's also going to take a little longer. The other thing is, most of the time, and I'll just write this down as a comment so you can see how comments are kind of interspersed in the code. So most of the time, you will import your data. So you're not actually creating your data from scratch, which is what we're doing in lines 27, 28 here. So this is just an exercise so you can see how data frames are really just, combinations of vectors. Because in practice, most of the time what you will do is you will import your data. And that brings us to the next part here, which is importing our data. Now, as an example here, what I have, if you look at the background here, in my desktop, I not only have the R tutorial script that we're working on right now, but I also have a CSV file. And it happens to be named tutorial.csv. That is the file that I want to import. Right? Now, this is one very important part which a lot of people who are new to R struggle with the first couple of hours that they're trying to use R. To import a file, you have to know where the file is. Now, there are different ways to do that. There are some easy ways to do that by clicking around from within RStudio, but I'm not going to do that because the hard way will be better for reproducibility later on. And by hard way, what I mean is you have to know exactly where the file is. You have to know the path to the file. So if you're using a Mac, for example, you can go, you can click on the file and right-click on the file, then click on Get Info, which is right here. This is going to give you some general information about the file, including where the file is. So this is the path to the file. If you copy this and you paste it here, you will see that it looks like this. Right? So as a rule of thumb, if you're using a Mac, your desktop will be inside /users/your username, which, this will vary, of course. So your username /desktop. So this is how you get to the folder right now. And this is why I'm saying that. If I want to import a data set, and I'm going to do that by assigning it to a variable, I'm going to use the function read.csv because this is a CSV file. And I have to now, inside the function, write the path to the file. And on a Mac, that path will be desktop, and then, of course, the name of the file, which you can already see here. And I'm using the squiggle or tilde here as a shortcut, so I don't have to write this whole thing over here. So you can substitute this whole thing with the squiggle. So if you're using a Mac, this is exactly, most of the time, unless you've changed it, but most of the time this is how you would access a file that's in your desktop right now. If you're using a Windows computer, you have to figure out what the path is for, to that particular file. The bottom line is you have to give R the exact address, so to speak, to the file. So if we run this line, we now have one more object here, and you can see it's right there. It's called D. It has 30 observations of 3 variables. Now, the very first thing you want to do with a data frame is to explore its structure, right? So we want to take a look at the data just to see if it looks okay. One way to do that is to visualize the top rows of the data, and that's done with the function head over here. So these are the first 6 rows of the data frame called D right now. You can see we have speaker, group, and score, 3 columns. Speaker and group are 2 factors, and score is a numeric column. Another thing you can do is use the str function, which stands for structure, and if you run that, it's going to tell us a little more about each variable. So speaker is a factor with 30 levels, so now we know there are 30 speakers in this hypothetical experiment. We also have the information here that the second column is a group, so the factor with 3 levels, the first 2 of which are German and Japanese, so we know there are 3 groups of native languages. We don't know what the third one is. And we have score, which is a column that contains integers or numbers, right? So head and str are two very, very important functions to explore the data. Another one that we can use is summary. It's very intuitive. If we run summary, we have a different view here. These are all accomplishing similar goals, which is really to give us the bird's eye view of our data without actually printing the entire table on the screen, which wouldn't be that useful in a situation where you have, for example, 100,000 rows or something like that. So the summary tells us that we have speaker as a column. We already knew that. We have one observation per speaker. So this is giving us the top 6 plus 24. So we have the 30 observations from up here. We also have group, which contains 3 levels, and now we can see all 3 of them, each of which has 10 observations. So we have German, Japanese, and Spanish. And then we have some basic statistics on the score column. So every time there's a column that contains integers or continuous numbers, the summary function will by default give us some general statistics about that column. So we have information like, this is the minimum score, this is the maximum score. So it goes from 68 to 90, but the mean is 78. And we also have some information about the quartiles and the median here. So these are different ways of exploring the data just to see if it looks okay and if it's ready for analysis. And this is really the very first steps that you would need in an analysis using R. Now the next one is really to manipulate, wrangle, and analyze your data. And I should also add here visualize. Now for that, we'll need a package. And packages in R are like bundles of functions, so they're kind of plugins if you are familiar with that. Every time you load a package, it's going to load a lot of functions that will help us analyze our data. Right now, as of 2020, there are about 15,000 packages for R. So the chances are that if you want to do something, there will be a package out there that does exactly what you're looking for. So packages are usually loaded at the top of the file. So at the top of the script, we'll go here and we'll load a package called tidyverse. Now, of course, to load a package, you have to first install it. If you have never installed any packages, you will have to type install packages and then type tidyverse inside the function. Now, it's very important to remember that you need the quotes here. So once you install the package, you can hide that particular line or you can delete it because you just need to install it once, and then you can just load the package by running library tidyverse. If we run that, you'll see down here in our console that a bunch of messages will be printed. It's just saying these are the packages that are being loaded when you load tidyverse. And you can see we have 8 packages here. So this is actually a bundle of packages, each of which has a bundle of functions. So we're just loading a lot of things that will help us navigate through our data and analyze what we want to analyze here. All right, so let's look again at the top rows of our data. So this is it. We have speaker, group, and score. Now, clearly, we want to see if the different groups have different scores. That's kind of, it should be clear by now, looking at the structure of the data, that that's likely what the person analyzing this data set would be looking for. So before we do that, let's try and do a couple of other things. Let's, for example, create a new column. So we can create a new column by using a function called mutate. So what we do here is we use the syntax from tidyverse, which is the following. We take D, and we're going to create a new variable that has the same name, so it's basically overriding what D used to be. We will take D, and then we will add a column by using the function mutate. Now the name of that column will be something, let's just do something very simple here. Let's do, let's square or take the log of score or something like that. So you could do, log of score is going to be this, right? So if you run that and you now visualize the top rows of D, you can see that we have the 4th column now is a new column. You can see it has numbers because it's taking the log of the score right next to it. So we can see you can create however many columns you want. If you wanted to create a new one, you would do it here. Let's say you wanted to create a column that squares the score of the participant. So if you run that, now we have one more column. So it's relatively simple to create a column. And you can also delete a column by using, for example, the function select. You can just remove new column like this, and now we don't have it anymore. Right? So these are simple actions and operations that you can apply to your data set using this symbol, which is the % greater than %. It's also known as the pipe. So let me just write that here. So this is the pipe, and you should read this as and then. So it's basically concatenating a bunch of actions and functions. Another thing we can do is we can subset our data. So for example, let's say we just want, remember we have Spanish, German, and Japanese speakers. For example, let's say we just want Spanish and Japanese speakers. We want to remove the German speakers here. So let's create a new variable called no German, or no G, something like that, something that's short. And that will be, a function that will take D and it will filter by looking at group, and group will be anything that's not German. So this symbol means not equal. That's why we use the exclamation there. So now if we look at no G, it looks like this. It looks exactly the same, but if you look up here in our environment, we have 20 observations for no G as opposed to 30 observations from before. So now we no longer have Germans in our data. And you can see that because if you get a summary of no G, you will see that for the German group, we have 0 observations now. So this is how we can subset our data. We could also subset our data by removing everyone who has a bad score. So let's remove everyone whose score is below 70. And we can do that by, again, let's create a variable called top for top scores. Take D and filter by looking at score above 70. Right, so if we don't want anyone under 70, it means that we just want people above 70. And if you run that, you can now see the top rows, and you can see that we have 71. And again, if you look up here in our environment, we have 26 observations as opposed to 20 or 30. So this is yet again a different data set. And if you get the summary of top, you will see that the minimum score is 71, whereas before, if you compare this with summary of D, the minimum score was 68. Right? So now we're basically removing things from our data set. These are some simple tasks and functions that you can use. Another thing we can do is we can summarize our data. This is incredibly useful. Let me give you one example. What are the mean scores for all 3 groups? Now, of course, we could just ask what's the mean of score, like this, right? So we're using the function mean. D $ basically means take D, look at D, and inside of D, look at the column score. So $ is indicating the column. If you run that, you'll notice that the mean score is 78.16, which you could also get by running summary of D, because it's going to tell you that the mean is 78.17 over here. Right? So this is rounding it up a little. But the problem is we want to know the mean for German, Japanese, and Spanish speakers. We want to separate the means. And so one easy way to do that, and this time I'm not going to assign it to a variable, is we can group by, and this is a very useful function, we can group by the variable group, which is one of the columns of interest here, and then we will summarize our data by calculating the mean of score. And this is what we get. We get a 3x2 table here where we have German, Japanese, and Spanish scores. So we know now that the average score for the German group is 84.8, for the Japanese is 77, and for the Spanish it's 72. So we have a clear trend here. Now you can also add more summaries here. Let's say you want to calculate the standard deviation. So you can just add a second column, and now we have 2 columns. So you can do all sorts of things with the summary function as long as you know the function that you're looking for. Now, this word, mean with capital M, this is just the name of the column. You can create any name. You can just type here, you could type cat here if you wanted to, and it would print, this is column cat now. Of course, this is your decision. But on the right-hand side, this must be a function. This must be something that R understands, so it has to be in the R lexicon. All right, so this is how we can quickly summarize our data set. The other thing that we can do here is we can transform our data from wide to long and from long to wide. Now, right now, if you look at D, this is in a long format. Right? So you can tell because it's long format table. I'm just writing this down here so you can kind of have the comments there. It's also known as tidy data because we have one variable per column. And this is great because this basically means that this is ready for analysis. But if you use surveys online, you will probably realize later on that that's not what happens with surveys online. What normally happens is you have something like a wide format. So let's see what that looks like. So let's basically transform our table to a wide format. And we can do that by using the spread command. So let's just create a variable called wide. Let's take D, and let's use the spread here. Let's spread group, and let's use score as our value. So now if we take a look at wide, it looks like this. Now we have one column for German, one for Japanese, and one for Spanish. And of course, because every single speaker can only come from one first language, every time you have a Spanish value here, so this is the score for the Spanish speaker, speaker 1, you will have NAs for Japanese and German. That has to be the case because you can't be a Spanish and Japanese and German speaker in this particular hypothetical study. So this is what you would get if you ran a survey on Google Forms or Survey Gizmo or whatever. And then, of course, what you would have to do is transform this, this wide format to long. Let me fix this typo here. So you need a long data set. So, and this is known as wide to long transformation. Of course, the opposite also happens. You can also do wide to long transformations. If you want to create a long table from our wide table, you take wide and you use the function gather. And this time, the key will be group or language, which is the name of the column that I want to gather a German, Japanese, and Spanish. So I want German, Japanese, and Spanish to be values in the column called group, which will be our new column, and I want the value to be called score. Now I also have to decide what to do with all these NAs here, and I'm going to use na.rm to remove all these NAs. And now, if we take a look at long, you will see that we have this. Now, where is our group? Where is the group column that we want to create? Well, we have to come back here and look at the columns that we actually want to transform. And the columns begin with German and they end with Spanish. So you can use colon here to mean from German to Spanish. If you run this again and run the top, you will see that we're back to normal. Now we have a group and a score column. So you can go back and forth just by using gather and spread. You can transform the data from long to wide and from wide to long again. And you end up with the exact same data set that we started with. Right? So this is something extremely important. It's usually the first thing you have to do as far as data wrangling goes for when you start analyzing your data. The next step is probably to create some figures. And I will here use two figures. I will use a box plot and a bar plot. Mostly because these are two very representative examples of what people normally do. So we will do that using ggplot2, which is a package that's loaded with tidyverse when we load that particular package. We run ggplot by using different layers. This is the first layer. It's a function called ggplot. It's the same name as the package. and we tell ggplot that our data will come from D. And next we use the AES statics function here to provide the arguments for the axes. So the x-axis will be group and the y-axis will be score. And this is the end of our first layer. The next layer will tell our which type of figure we want to create. And in this particular case, I want to create a box plot. So if we run this line, we have a box plot where we have German, Japanese, and Spanish on our x-axis and the score on the y-axis. Now, if you don't remember what a box plot is, it's basically showing us the spread of the data. So the thick horizontal lines represent the median, the boxes represent the cluster of the most frequent 50% bulk of our data. So you can see that the boxes represent really the most important part of the data in the sense because it's kind of clustering around that area. And then the whiskers represent the rest. Right? Every little dot that you see here, and we only see one for the German group, that's an outlier. So basically 99% of the data roughly doesn't include that particular person there. Right? So there's one person here that's really kind of an outlier for the German group. Japanese and Spanish groups don't have outliers. So this is a simple box plot. A bar plot can be done in a similar way. Of course, the first layer will be the same because we still want the group to be on our x-axis and the score to be on our y-axis. And then we do the StatSummary function. Now, StatSummary is a great function coming here from ggplot because it includes not only visualization but also some statistical summaries. If you run it, we'll see that we have little dots here. The dots represent the mean, and we have some whiskers that really represent the standard error from the mean. Now, you may not remember what standard error is, but this is basically how certain we are about the population mean given the sample that we have at hand here. The technical definition of standard error is that it's really the standard deviation of the sample distribution of the sample mean. So that's a mouthful. The easier way to remember what it is really to think about certainty. We don't want to say that the mean of the population is exactly the mean of the sample because we never know that for sure. So we want to provide some level of uncertainty. And these standard error bars are doing exactly that. So this is called the point range. We can also come in here and say that we want an error bar instead of that default point range geom. So we can have an error bar. And now we have something like this, which looks like Roman numeral 1. Of course, you can change a lot of this. You can change the width of the error bars. You can say like 0.2. So now it looks a little thinner. So these are our error bars. We can also add multiple layers. So let's imagine that we want to add a bar as well. So this is what's going to happen. This will look ugly at first. Let me show you. Okay, so this is going to look a little odd because now we can't see half of the error bar, and that's because the error bar layer is specified before the bar layer. So we could just move this up here, and now it would be in front of the bar. But it's still weird because the background is too dark, so one way to fix this is to add transparency, and we do that with the argument alpha. Alpha goes from 1 to 0, or from 0 to 1. 1 means totally solid color, which is exactly what we see right now. 0 means completely transparent, so you will not be able to see the bar if I run this code. Right? So the error bar is not there anymore. Now, of course, we want this to be here because we want the bars to be transparent, and now the bars are not shown. You can't see it. But we can add color to the borders of the bar. So if we add black here, you will see the borders of the bars like that. Right? So this is kind of just to show you how we can add some formatting functions inside of ggplot to get the job done. Now we can see here that it's probably the case that these groups are all different because there's no overlap across the error bars that we see here. And if we look back at the box plots at the top here, the box plots are also not overlapping, very little overlapping over here. So we can already anticipate what's going to happen when we try to run some statistical tests. And here I'm just going to run two very simple tests, one Ttest, and I'll run an ANOVA just to show you how to do that in R. And just to be clear, we don't normally use ANOVAs and Ttest these days, but these two methods are actually what we see in English 601. And that's one of the main reasons why 686 exists, really to provide better methods and more up-to-date statistical techniques, so you can actually go ahead and deal with different types of data. So now we come to the stats, right? So this is the typical set of steps that you have to follow when you're doing your analysis. Remember, going back to the top, we imported the data, we visualized it, we took a look at the structure to understand if everything was okay. Then we created some figures. We also summarized the data at the top here using group by and summarize to get some information about the means. So this is normally what you do before you run the stats. You should not run the stats from the get-go, because it will just give you numbers and you don't really understand what's happening to your data and if your data looks the way you think it should look. So the final step here is really to run some stats. Now here's the thing: we cannot use a Ttest with the data the way it is right now, because a Ttest requires only 2 groups. So we can do that because there's the no-G data that we created before, and the no-G data has no German speakers. So this particular data set only has Spanish and Japanese, and you can see here, if you run it, you can see there's only Spanish and Japanese speakers here. So to run a Ttest in R, it's actually pretty easy. You just use the function t.test, and then the first thing we have to say is what the dependent variable, or better, the response variable is, which is score. Then we use a tilde to introduce the independent variable here, which is group, and we tell what the data is. We just indicate here what the data set is, which is the no-G variable. Now, one thing that's important, so this is our dependent or response variable. This is our predictable variable, predicted score versus predictor variable here. You will also see all over the place people referring to this as the dependent variable and this as the independent variable, which is a little misleading, but you can also call group your independent variable for now. So if you run this, we will get our result here. This is a 2-sample Ttest. Here you can see the T statistic, which is 2.4. This is our degrees of freedom. You can see it has decimals because it's assuming that equal variance is false. So this is not going to be the same degrees of freedom that you would get if you were manually calculating it. And you have a p-value here, which is below 0.05. So here we would reject the null hypothesis that Spanish and Japanese have the same mean, that they come from the same population. And this is kind of obvious when you look at the box plot, considering that there's very little overlap, or when you look at the bar plots, because the Spanish group has a mean that's under the mean of the Japanese group, even if you consider the standard errors here. Now, it's extremely important to have standard error bars if you have a bar plot. Bar plots that have no standard error bars are provide very little information. So 99% of the time, you have to have error bars, at least to give people some level of certainty about the location of the means. So this is a typical Ttest, and you can see it also tells you what the mean of the Japanese group is and the mean of the Spanish group. So we have like a 5-point difference between the two. It provides the confidence interval, so it goes from 0.3 to 10. So this is a pretty wide interval. And the reason why this is wide is because if you go back to the box plot here, using the arrow here, you can kind of navigate through the plots we created. You can see that the Japanese group has a huge spread compared to the Spanish group. And so this is, of course, going to affect our statistical analysis here. Finally, we can run an ANOVA. And ANOVAs can be run using the AOV function, which stands for analysis of variance. And this time I'm going to assign it to a variable. Let me call it stat2. In the Ttest, I'll call it stat1. Of course, if you run it like that, now you have to run stat1 here to get the output. So the nice thing about having a variable and assigning your statistical test to that variable is that you can refer back to it later on in the script. Now we do the same thing here. We do score as a function of group, only this time we can use the original data set that contains 3 groups, because ANOVAs can totally analyze multiple groups, that is more than 2. If you run it and now get the summary of stat2, this is what you'll see. You'll see that group has a statistically significant effect. We don't know which groups are different from which groups. We just know that we have to reject the null hypothesis that there is no difference in means across all 3 groups. Now, to figure out where the difference is, we need a post hoc test. And one possible post hoc test is a Ttest. So we can run that on top of stat2, which is our ANOVA, and here we will get all the comparisons, Japanese-German, Spanish-German, Spanish-Japanese. This is going to tell us the difference in means. This will tell us the lower and the upper limits of the interval, and this is going to tell us what the adjusted p-value is. So you can see that all 3 p-values are under below 0.05, so all 3 differences are statistically significant. The nice thing is that you can easily plot these results by using the plot function, which is not coming from ggplot, this is coming from base R, then Ttest, and then our object here, our ANOVA. If you run this, you will see the comparison here as a plot. And this is giving you the difference in means in the middle and the confidence interval. Now you can see 0 down here has this dashed vertical line crossing all 3 comparisons, and this is the confidence interval. Now, the confidence interval cannot touch 0 if you're looking for a significant p-value. So you can see that all 3 intervals are under 0, below 0 here. No interval touches 0 or crosses 0 or includes 0. And that's why the p-values here are all under 0.05. That is the reason. Right? And you can see here that the Spanish-Japanese comparison is the one that has the highest p-value, still significant, but much higher compared to the other 2 comparisons here. 0.03. It's almost not significant. And you can see here that the Spanish-Japanese confidence interval in the Tukey post-test is almost touching 0. So this is just a visual representation of what we see here in the output. And in fact, when we ask the plot function to plot the output of the Tukey test, this is exactly what it's using to create the plot. So these should match 100%, obviously. So this is how you perform a very simple one-way ANOVA and take a look at a Ttest output, so a post hoc test, to find out where the difference is coming from and plot the results. So this is a very brief summary of the most important things that we discussed in 601, and this should be your starting point for 686. This provides a pretty good overview of what you should be able to know at this point if you're planning to take 686. Feel free to watch this several times if this is the first time you're watching it, and if you're not familiar with R, but also use this to review everything that we saw in 601 if you took that course recently. And this is all for today.